Hi everyone, I am Jiachen Wang from Zhejiang University. I'm going to present Tac-Anticipator, visual analytics of anticipation behaviors in table tennis matches. Anticipation skill is the ability to capture and interpret the current information to prejudge future events. For example, in table tennis, after the player hit the ball, he or she would anticipate the opponent's actions. If he or she anticipates correctly, then he or she can take control of the match. In contrast, if he or she anticipates wrongly, he or she may lose the match. Let's see a real example. This is the wrong anticipation behavior of the male player in yellow. He prepared in the opposite direction when receiving the opponent's stroke. Let's see it again. Therefore, good anticipation skill is very important. To improve players' anticipation skill, considerable works have been conducted since 1970s. These works investigate players' anticipation behaviors from the cognitive perspective through interference-free experiments. Specifically, the participant need to watch an occluded video and anticipate the behavior of the player in the video and then respond to the behavior as soon as possible. To discover different factors affecting anticipation performance, the occluded videos are designed based on two paradigms: temporal occlusion paradigm and a spatial occlusion paradigm. The temporal occlusion paradigm occludes the last several frames of the video, and the spatial occlusion paradigm occluded several body parts of the players in the video. During the experiments, participants' reactions are recorded by sensors and cameras for further analysis. In this way, players' anticipation skills are measured and studied comprehensively. Besides the in-lab research, several works also studied the anticipation behaviors in real matches. These works extract the response time and accuracy of anticipation behaviors from match videos for analysis. While these studies have discovered many valuable insights, they are not comprehensive enough since they did not consider enough contextual factors. To fill this gap, we propose Tac-Anticipator for visual analytics of anticipation behaviors in table tennis matches. Before introducing our work, I will introduce the definition of anticipation behaviors. Here is an example of the anticipation behaviors of player A. A is purple and B is yellow. After A hit the first stroke S1, he may start to anticipate player B's second stroke S2. If he confirms his anticipation, he would change his position or poses to prepare for his third stroke S3. And during this process, the phase between S1 and S2 is defined as the anticipation phase of player A, and the one between S2 and S3 is the reaction phase. And therefore, in this work, we mainly pay attention to player A's behaviors in anticipation phase, namely his anticipation behaviors. To develop Tac-Anticipator, we encountered two challenges. The first challenge is about the acquisition of anticipation data. There are many factors affecting players' anticipation, for example, their positions and techniques. How to decide the key data to collect and how to collect these key data is really studied. To solve this challenge, we collaborated with experts from the Chinese national table tennis team and determined three kinds of data to characterize anticipation behaviors, namely attribute data, trajectory data, and event data. The attribute data includes technical attributes of players' strokes, such as the technique, position, and placement. The collection of this kind of data requires domain knowledge. Therefore, we developed an interactive tool for our experts to collect the data. The trajectory data includes the trajectories of all players and the board. To facilitate the collection, we referred to event anchor proposed by Zheng and developed a customized collection tool. The tool would automatically check the players and the board first, then users need to check the video and revise the run checking data. The event data includes the board rack contact, the board table contact, and the board flight. This kind of data is collected when checking the tracking data. The second challenge is how to analyze the anticipation data, since such kind of data has rarely been studied before. To solve this challenge, we first proposed an evaluation function to evaluate the performance of each anticipation behavior. Based on the function, we designed and developed a visual analytics system, Tac-Anticipator. Before introducing the system, I will introduce the function first. The function evaluates players' anticipation behavior from two aspects: anticipation efficiency and moving efficiency. The first is anticipation efficiency. After the player hit the stroke, he would take the serious actions to prepare for the third stroke. To evaluate whether the player anticipates and takes action rapidly, we use the variation of the distance between the player's current position and his final position at the third stroke. If the distance reduces rapidly in the anticipation phase, namely between S1 and S2, then the player anticipates and takes actions rapidly. The value of this function will be large and near to 1. The second is moving efficiency. This function evaluates whether the player anticipates correctly and takes action efficiently. We refer to the indicator of route efficiency to propose the function. This function divides the distance variation by the length of the trajectory during the anticipation phase. If the player anticipates correctly, the value of this function will be large and near to 1. With the two functions, we use exponential functions to integrate them, avoiding negative values. We use sigmoid function to give lower scores to actions, where the player does not move for enough distance. We summarized experts' analysis tasks as follows. Based on the tasks, we derive the design goals of the system. And here is the system design.
Tac-Anticipator consists of 3 views, namely the match list, the navigation view, and the anticipation view. The match list displays match names, match scores, and player information in each match, including player handedness, racquet type, and racquet covering. By clicking the match, analysts can investigate the anticipation behavior in this match. The navigation view displays the similarity and evaluation scores of anticipation behaviors. We project all anticipation behaviors based on their pairwise similarity. Each anticipation behavior is encoded by an on-field circle. Users can choose points by box or lasso selection. They can hover over the point to preview the anticipation behavior. They can change the encoding of the circle color. The evaluation score is displayed as bar chart. The bar chart has 2 modes. One mode displays the difference in average evaluation scores between two sides within the rally, and the other shows the specific value of their average evaluation scores. The field circle represents the winner of this rally. Users can choose bars by box selection. They can switch the mode by clicking the Difference button. The legend above can be used for data filtering in the navigation view. The anticipation view consists of two parts: a panel to show anticipation curves and a video player panel. We designed the anticipation curve based on the original moving curve. We first split the curve into two segments, one in the anticipation phase and the other in the reaction phase. Then we add the 4-stroke attributes of the 3 strokes to the curve segments. We visualize the distribution of different attributes of all anticipation behaviors displayed in the anticipation view. We use luminance to encode the frequencies of different attribute values. The darker, the more frequent. We also display the simplified trajectory beside each curve segment. Other details, such as the result and the evaluation score of each anticipation behavior, are added to support in-depth analysis. Users can sort the curves based on the results or evaluation scores. They can use the legend, the slider, and the attribute panel for filtering. Once they choose a particular curve, the video player will play the video clips of the corresponding anticipation behavior.
We conduct an experiment to evaluate our function. We first calculate the scores of each anticipation behavior within the match based on our function. We categorize the top 30% as good and the bottom 30% as bad. From the good group, we selected 2 behaviors for each player, and similar operations are conducted in the bad group. Then we create comparison groups within each player and between 2 players. In this way, we have 8 comparison groups. In each group, our expert need to watch the video of the 2 anticipation behaviors and then decide which one is better. According to the result, our function could tell good behaviors from bad ones as accurately as the experts, regardless of the players. Here is the case study based on the system.
This case is the final of the men's single in the 2019 Men's World Cup between Fan Zhengdong and Harumoto Tomokazu. The expert first investigated the scatter plot in the navigation view. By hovering over some points, he found that actions on the left have monotonically decreasing curves, indicating more efficient anticipation behaviors. Actions on the right are non-monotonic with troughs or peaks, revealing inefficient anticipation behaviors. He was more interested in those efficient behaviors, so those points on the left were chosen. He examined the distributions of the stroke attributes of the 2 players separately. The technique distributions of the second and the third strokes are similar between the 2 players. The darkest point is topspin, a frequently used technique by players with a shakehand racket having 2 in coverings. This finding confirms his knowledge. He set the sliders to only show the anticipation curves with a score larger than 1. He found the distributions of stroke placement in the second stroke of the 2 players are quite different. Fan used long backhand more frequently, with a score of 0.69, implying that Fan was good at anticipating Harumoto's strokes hit to the long backhand. He explained that if Fan hit the stroke to Harumoto's long backhand in the first stroke, Fan would anticipate the opponent's stroke more easily. This is an interesting finding. Moreover, from the position distribution, he found that Fan was also good at anticipating Harumoto's strokes hit by backhand. This further confirmed the above finding, because players often receive the strokes at long backhand with backhand. For the stroke placement and stroke position in the third stroke, he said that the difference between the two players was insignificant. In the end, he concluded that while the anticipation behaviors of the two players were similar, Fan's anticipation exhibited some unique characteristics. He could easily anticipate Haramoto's strokes received at long backhand with backhand. This suggests that Fan should hit the stroke to Haramoto's long backhand.
Our experts give 3 suggestions about the system. First, they hope that the system can consider more behaviors, such as back and forth movements. Second, when analyzing doubles matches, they hope the system can also consider team-related activities. Third, they thought the effect of tactics can further improve the evaluation function. In summary, we proposed a visual analytics system for analyzing anticipation behaviors in table tennis. The system can be generalized to other sports such as soccer and tennis, and even to other fields with similar spatial temporal data. The main limitation of this work lies in the data collection method and the limitation of one match each time. In the future, we will consider more factors such as players' postures and the tactics in the system. And that's all. Thank you.